Okay, this time I'm recording. Forgot yesterday. Recording resumes. Recording means that this will be available on YouTube later. And I'm going to start doing more screen shares. Aha, there it is. You guys there?
Yeah.
You guys know how to go back and forth between your tabs so that you can click on me, or you can go to the screen I'm sharing.
Actually pinning in.
And this way, you guys don't have to keep asking, well, I can't see the screen and stuff. I'll have it up there, but I think I'm needing it less and less. And that's your warm up, so you can go ahead and get started on that. And good morning.
Good morning.
Good morning, everyone who is currently on this Zoom call.
Good morning.
Bruh, only 30 people.
Who cares?
Let's mute ourselves unless we have a question.
What's the difference between the median and the mode?
The mean is the average of the data.
The median and the mode.
You said between the two, so I'm going to tell you what one is, and then I'm going to tell you what the other one is. So the mean is the average when you add them up and divide by how many there are. That's the mean. The median.
You said median.
I said median and mode.
You guys would just let me finish, you know, and you're going to hear your answer. I promise you. Just be patient. Okay, so I explained what mean is just now. Now, median is when you order them from least to greatest, and you pick the one in the middle. Now, if there's an odd amount of data, there'll just be one in the middle. That's your median. If there's an even set of data, then you're going to have two in the middle. And then you'll have to take the mean of those two, and that would be the median. You have to average out the middle two if there's an even amount of data. Okay, almost there, almost 10.
What's the mode?
Mode, you focus on that long O, mode and most. It's the data that shows up the most.
Okay.
If no data stands out more than any other data, then there's no mode. But if you have two pieces of data that stand out, or 3 or 4 or 5, there's not really a limit. But if you have data that stands out, then you'd have multiple modes.
Why would you want to find the median?
Different reasons. As we go through, you're going to see different reasons. Median, I'll give you an example I gave yesterday. Median household income, or I said median house price. The median is good because it tells you, because it's actually in the middle, exactly the middle data point, that means that half of the data literally is underneath it, and literally half the data is above it, right? So that's what a median does. It tells you half of the data is below, half the data is above. The average does not have to have, there could just be one person that is above and everybody else is below. So take wealth, for instance. You know, if you've heard any politics, they talk about the top 1% or the top 10%. When you get people that have $80 billion, right? That's going to affect the average. That's going to drive the average up, right? So when the average is up, you're going to have more people below the average than above it. So that's a different calculation. You might not want to use the average if you have what we call outliers, but now we're getting ahead of where we are. We're going to get to outliers. Outliers like the $80 billion amount of wealth that somebody might have will skew the average. It will make the average not as accurate. So what you try to do to get a data set to be accurate is, if you can, if it's practical, you remove the outliers. And the reason you would be doing that is to try to see how the data is behaving. Now, why do we want to know how data is behaving? So that we can make informed decisions about different things. Okay, all right. This problem, let's get into it. It's time to get started. So you can make my screen bigger if you'd like to see me doing it. You can keep it on the other screen, it's your choice. I'm gonna put F for Fitzgerald's, and I'll do it, or I like horizontally, left to right. And I'm gonna order them least to greatest. So I have 18, 20, this is the Fitzgerald family, 22, 47, and 50. Okay. And then for the other data set, that's going to refer to the Cordero family. And they're going to have I have a 4 and a 5-year-old, a 9-year-old, a 35-year-old, it's a big family, a 42, oh, and a 2, look at that, brand new, and a 78-year-old and a 42-year-old. They have more data points in there, don't they? They have 5 people in their family. This one has 7 in their family. Okay, but you can still compare their means and medians. So if we want to grab let's go ahead and grab their medians right away. Well, it's the number right in the middle. And you can go left, right, left, right, left, right until you find the middle, especially when there's a lot of data. Here, if I go left, right, left, right, left, right. Those are the medians. Look at the median age. Half of the people in the family are below the median age. The other half of the family is above the median age. Okay? Here, this half of the family is below that age, and the other half of the family is above that age. Okay? So it appears that now, because this data set is so small, it doesn't tell you too much. We don't usually do data that is only 5 data points. It's hard to find a situation where that would matter. But if you want to do something like this for the median age of a country, and they do that. So I think Japan has one of the oldest median ages. So if you took all the people in Japan and you took the median age, I think it's 10, 15 years higher than what we have in the US. So what do you learn from that? You learn that they have an older population there. Well, why does it matter if they have an older population? Can anybody give examples of why it matters if your population is older than another population?
People live longer.
Okay, maybe you're saying that they live longer, but that you don't necessarily know that.
Less people die, I guess.
It could
Every
mean
year.
that. There could be a correlation with that. We don't know if that, but maybe. What else?
Also, if you're gonna
Less
try
people
and
leave.
It has to be like
Less
systems
people
that
born.
like help elderly people.
Couldn't it mean there are fewer younger people?
yeah, if you're trying to make a kids TV show or something, you probably wouldn't bring it to Japan, maybe.
The younger people are less appropriated.
How about this? How about where the wealth is? Who is more likely to have wealth? Younger people or older people?
Younger people.
Older people,
Older people.
And
because they have more time to earn wealth.
You've had
Rich
more time
people.
to earn wealth, exactly. So if your population is older, would that correlate with a wealthier population?
Yeah.
Yes. Yes.
Kind of.
These are important things to consider. You know, if the older you are, the more likely you are to have wealth. It doesn't mean that everybody is going to be wealthy. These are large numbers that we're talking about. It does not apply to individuals. It's just for large numbers. Okay. And then, of course, we can do the mean. Let's do the mean of these. So I'm going to add these all up and divide by how many there are. 38, 60, 107, 157. Divided by 5. 3, 1, 31.4 for Fitzgerald's. That's the median. I can put mean for Fitzgerald. Mean for Cordero. Let's see. 6, 11, 20, 55, 97, 175. 175 divided by 7 to, oh, it's 25. So it tells you kind of the same thing, that the Cordero family on average, the Fitzgerald family on average are older than, doesn't mean that they have the oldest member. They have a 78-year-old in the Cordero family. But on average, the Fitzgerald family is an older family. If you look at it, look at all the young people here. The very young people. So they have very young, and they have, you know, some older people and one much older, right? But look at them. Look at the Fitzgerald family. They don't have any small children. Their youngest member is 18 years old. All right? So this is an older family. All right? Now, let me say to you, that doesn't mean that they're wealthier, you know, that you can't do that with the smaller numbers. There's not enough numbers here because you don't know, one person can have a lot of wealth. But when you average it out to hundreds of millions of people, then you have just as many, you're not just as many, but you're going to have a lot to balance it out on both sides. You'll have people with nothing versus people with a tremendous amount. You'll have outliers on both sides, and they kind of tend to cancel each other out more the more data you have. So you're going to need more data to have an accurate reading of to have any meaning applied to this. You're going to need a lot of data. So you're just getting the process at this point.
I saw this problem in the homework.
Mm-hmm. Okay, so the mean age of the Fitzgerald family is more, and also the median age is. Okay, any questions before we move on? All right.
Question, what's the difference between mean and medium?
Median?
Yeah.
Well, look, can you see my screen?
Yeah.
What's the difference in what I did? What did I do here in this box?
You put the middle one?
I picked the middle one. That's the median.
Uh-huh.
Okay, that's for the Fitzgerald family. That's not the same number I get when I find the average, the mean.
Okay.
Well, how did I get that one?
You added up all the numbers and divided it by the amount of numbers, which is...
Okay, so you can see what the difference is between them.
Yeah.
Okay, let me ask you about the Fitzgerald family. Are exactly half the members of the family less than under 31 years old?
No.
No.
Yes.
3 of the members are under 31. Only 2 of the members are above it. How about for the Cordero family? How many are below 25 years old and how many are above? It's 4 below, 3 above. Okay, so almost half the data is on either side here. Okay.
Okay.
Right? But with the median, exactly half are below and half are above. Exactly half are below, exactly half are above. Okay? Gives you slightly different information. All right. Choosing appropriate measures. So that's kind of what you're asking is, what do you do? How do you know which one to use if you're actually conducting a study? So you guys are going to have science fair next year. Use this information to get, if you want to win the science fair, You got to take a lot of data and you got to know how to do the statistics on it and to form a reading. You can do this in your next science fair project where you can use mean, median, and mode, or pick one and make sure you know why you're choosing it. So this is where we're going to learn that now. Okay, so look at what this suggests. And I'll bring it up over here as well. Go ahead and look at that. Okay, so this says the mean, when is it most useful? The data have no extreme values. Remember, what did I call those?
Outliers.
Outliers. If they don't have outliers, the mean is good. It's a good, values that are much greater or much less are the outliers. If it doesn't have that, mean is usually, this is not a rule that you always have to do that. It's just something to look out for. When data has outliers, the mean is going to be skewed and it won't be as accurate. So when you see a data set that has numbers that are way bigger or way smaller than the rest, the mean might not be as good of a measurement. But if it doesn't, then the mean is probably a good, accurate measure of the middle of the data, the average. Okay, median. Why use the median? When the data do have extreme values, like the 78-year-old, okay, that's an outlier, then the median is maybe a better indication of the middle than the mean. Okay, because that 78 drove the average up for that family, for the Cordero family. Look at most of the members of the family. 2, 4, 5, and 9 years old on my screen. Okay, so, you know, because of the outlier, it made the average seem much higher than what a lot of the people are. Okay, but if you see 9 is way different than 25. Then it says that half of the people in the family are going to be under 9 years old. That's maybe a little bit more accurate for me. Half the family is very young and half the family is going to be older than 9 years old. Now it's not, again, it's not a lot of data. So that's a bigger range. Under 9, okay, I'm dealing with small children, that's useful. Those children need to be supervised. They're minors, they have different rules, you know, but over 9, I don't know, it could be 10. They could be 11, they could be 12. So because there's not enough data, it doesn't tell me a lot of what's going on above 9 if all I told you was about the 9, right? If I didn't have any other data here, I just said the median age in this family is 9, and I didn't tell you what the other people were, you wouldn't know much about everybody older than 9. But you're probably close enough because you're not going to go below 0. Your range is much smaller down here. All right, so no big gaps in the middle of the data. Well, that's the problem here, is that in the middle of the data, there's a big gap between 9 and 35. There's a big gap here between 22 and 47. So maybe the median was not amazing here, okay? All right, mode. When is mode good? Mode is good when data have many repeated numbers. If you're getting 20 showing up over and over and over again, it might just be better to say the average person in the family is 20 years old, right? So, you know, you could do that with the population of a country. You could say which age, is there an age that comes up way more? Like if you take the population of the United States, and there's more 24-year-olds by far than anybody else. I just don't think that would be a great measure though. And I don't think that that's the case. I don't know if any numbers of ages stand out that way in a meaningful.
The country with the biggest medium age, or the oldest median age, is Monaco with 53 years, I think.
So the
Monaco?
so the median age person, that means half the people are below 53 and half of the people are above 53. Yeah.
Yeah, because yeah, that's yeah.
Okay, so we're gonna, any other questions about this? Yeah, and I recommend you do what Charlie's doing, is looking stuff up like that to see data sets and see what you can learn from them. Okay, here's table 3. This table shows the high temperatures for the previous week. See, we're giving you different examples of data. Which measure of center best represents the data? justify your selection, and then find the measure of center. So this one is not just about being able to find mean, median, and mode, which you should do. But before you do that, pick the one that is the best and go up to that chart that I just showed you, if you need to look again, to see which one is the best one to use. Try that now, take 2 minutes, go. I know what I'm doing. I'm just gonna look for certain things here.
What does it mean by which measure of center?
What are the 3 measures of center that we've been talking about?
Oh, mean, median, and mode. That's what.
Yeah. So which of those is the best?
Okay.
Those are all measures of where the center of the data is. They used to call it measures of central tendency. That's where does the data tend to be on average. Averages are good to really describe large numbers of data. They're not really good for the individual. It doesn't tell you anything about the individual to know what the average of a large population is.
What about the average credit score or something like that?
Of a population, it doesn't tell me what the individual's credit score is. So if you come up from a population that has a high credit score population on average, it doesn't mean that you individually have a high credit score. So I cannot base a loan that I'm going to lend you money on off of the population's average credit score. I have to base it off of your individual credit score. So it's not helpful. Okay, I'm going to start pointing anybody want to point some things out that they noticed about the data?
There aren't that many outliers. It's pretty, it's within a pretty like steady range. I should
Steady
say.
range, small range, yes.
So
Yeah.
80 to 90.
No outliers. Are there lots of repeated values here?
no,
No,
No.
there's none.
We don't need the mode.
yeah, and there's no big gaps between because it goes from
We
90 to
need the
91.
median and mean.
Okay, so what did it say up above about median? If the data have extreme values that are way different than the rest of the data, the median is a good one to use. And if there are no big gaps in the middle of the data.
Well,
Here's what a big gap looks like. If you want to look at my screen, is if I have this. What about all the stuff in the middle? Look at that. It just jumps and then it steadies out again, right? We don't want this this would be bad for median. Okay? Because then, the median might end up being, let's see, I had 4 here and 4 here. Let's put another 1 in here, right? That could be the median. And then look, this data is close to that one and this one's not. So it's not useful to have the median when there's a jump in the middle. You don't want to jump in the middle. But if I have outliers on the edges of the data, then median would be good because then most of the data is within a tight range except for those. So what did you guys come up with? Which measure of center are you going to use?
Median.
Yeah, I would say I would say
said median.
I used mean.
Oh, I should put up the chat. I can't see the chat right now.
Mean or median would be fine.
My chat disappears. Let's see more. Oh, chat. Here we go. I have the chat now. I wouldn't say median. You know why I wouldn't say median? It said use the median when you have extreme values. When you have outliers, median would be good. It doesn't mean median is bad. Median is I would say median is an acceptable answer, but according to the chart they just showed us, I think mean would be the most appropriate here. All right, so I'm going to find that. Okay, let's see. 8 times 5 is 40, so that's 400. And then let's see, 7, 16, 21. 421, 580, 602. That would be-
We can't see the table.
You can't see the table? Isn't it on shared screen?
Is that still up? Oh, it is. My bad.
Yeah. I think the shared screen's working well, actually. So 602 is my total. I wonder if you guys got the same thing. Divided by 7 data points. Okay, so 7 times 8 is 50.
I got the same thing.
It's 86 exactly. So the mean, by the way, when you get to AP stats, the mean will be that. X with a bar over it is what they use for mean. So if you want, I can give you that notation. Students are going to ask, what's that? That's mean.
Average is 86, I think.
Yeah, and that looks good to me. Then you look at it and you say, does that make sense in the data that the average temperature is about 86? Yeah, that seems right to me. An average temperature of 86 degrees. Again, what's the problem with what we're doing right here? Can anybody, from what I was telling you before?
We hit a new amount of people here.
Oh, 63 participants. Excellent. We need more. We need everybody. We need everybody. Okay. Any questions about, does somebody answer that last question? What's wrong with the problem? How useful is this? What does this tell me?
It tells you the average temperature
That
in that week.
over a week's period?
Over a week's period, yeah.
When would you ever use that?
Weekly temperature.
Because it's an more accurate forecast than
Well,
what
you guys
a
studied earth science, right? What's the difference between weather and climate?
Weather is day to day, climate is over a long period of time.
Over a very long period of time, right?
Yeah.
Can't just be seasonally. It has to be over what, decades, hundreds of years, right?
Yeah.
You get these zones, these climate zones or biomes, right? All right. So how would we say, what would be important then is temperature part of the formula for how we determine a climate zone? Precipitation is one of them, right? How much precipitation an area gets, right?
Yeah.
And don't the temperatures range in different climate zones, like the tundra, right?
Mm-hmm.
Okay, so those are temperatures averaged out over what? Over long periods of time. This data set is too small to mean much to us. So what? You have the average temperature over a week. When you turn on the news and they do the weather report, do they ever tell you what the average weekly temperature is?
nope.
No.
Never, because it's not important. Okay? When would data about temperature be important on average temperature? When you're talking about climate, right? Okay, and then you also want to talk about ranges. In the desert, what's the range in the desert? It's a big range, right? At nighttime in the desert, very cold. Not as cold as the tundra, but it gets cold. And you have a giant temperature swing in the day, right? It gets super hot, okay?
It does snow in some cases in some deserts, so that's also a.
How about where you decide to live one
factor.
day? Do you think people, when they decide to live in a place, they care about moderate ranges of climate, where it doesn't change much? It stays within the same range, with a small range of temperatures. So if you live by the ocean, what happens when you live by the ocean? You learn this. You learn this in earth science too. You have the ocean,
The ocean regulates the temperature.
and you have the land, right? You have the ocean and the land. What happens to the molecules over the land compared to the molecules over the water during the day?
The water has a higher specific heat, so it can trap in more heat, and it doesn't like not as hot.
The particles of air above land during the day when it's heating up versus the particles of air above the water during the day. Which ones heat up faster?
The
land.
ground, because it has less, has more surface heat, doesn't it?
Has a
Oh.
lower specific heat.
Yeah. Okay, that's the one.
This air is going to heat up faster during the day. Okay, that means these molecules are going to spread out from one another. What's that going to do to the pressure?
It's going to decrease the pressure because warmer air is less dense, creating less pressure in the air.
That's right. And the cooler air
Is more dense
gonna
and
condense.
has.
going to condense because of the temperature. So there's more pressure. And when two clumps of air, bodies of air that have different pressures meet, different temperatures, what's going to happen?
It creates a front.
They're going to meet. They're going to come together and mix to create equilibrium. So which way is that going to go? High to low. So you're going to get a sea breeze.
Convection current.
Okay, so that's going to come onto land. What is that going to do to the hotter temperature? Whereas here's some mountains here, right? And then you have the valleys that we live in. This temperature is going to be what this one was before this blew onto land. So this stays at a certain temperature that's hotter. This one mixes with cooler air and cools off. This climate zone is going to be different than that climate zone, and you're going to see it in the data. The data would show you. And you would use averages over not a week, you would show averages over long periods of time. What happens at nighttime? Which one cools off faster?
The land.
The land cools off faster at nighttime, so these become condensed compared at nighttime compared to these, which will be spread out compared to those. And then what you get at nighttime is a land breeze. So when this cools off to a low temperature, this then is going to come out to the ocean with a land breeze, mixing the two temperatures, which will keep that temperature from going as low as that temperature. And this could be a desert, this could be valley, I don't think valley is a climate zone, but what happens in the valley is a phenomenon. Okay, if you look at the news, what are the reports they give you? They tell you the temperature in Los Angeles, in the city. They tell you, and they tell you the temperature at the beach. They tell you the temperature in the inland valleys, and they give you the mountain temperatures. So why? Because those are different climate zones. They have different data. They have different average temperatures. Okay, so it doesn't make sense just to show you the temperature in Los Angeles. It doesn't apply to the temperatures you're going to see in the valley, where it doesn't mix with the ocean air. Okay, but what does this do to the range of temperatures? It can't get too high because it'll mix with the cooler during the day, and at nighttime it can't get as cold because it mixes with the warmer air over the water at night. So the range of data is going to be affected. You're going to have higher lows and lower highs. Here you're going to have more extreme data. At nighttime it's going to cool off much more. It'll be super low. And in the daytime it gets super hot because it doesn't have any air, other types of air to mix with. Unless the air can get over the mountain. Okay, now you have mountain climate up here because you have stuff being pushed up here, right? And then, this is the windward side. What do you guys, what's this side of the mountain? You guys know what that side of the mountain is?
Leeward side.
Leeward side. What happens as this moisture comes in and you get precipitation in the mountain, and then as it comes down, you get this dry air that comes down here. So on the leeward side of a mountain, if you were to travel the 14 freeway to Palmdale, what do you see when you get to Palmdale?
It's science now.
Desert, right? You see desert. You get the dryness, which
Is
affects
there a big
all
near
the
the
data.
side?
It's tied into the data and what you're using data for. So why I did that, the reason why I went into that is because I want you guys to see that the data that we're talking about, they're giving you examples that are small data sets so that you can learn the process of going through this. But it doesn't answer the question of meaning. It doesn't mean much unless you have large numbers of data. Okay, moving on. Let's go ahead and scroll down over here. Let's look at our next data set. This table shows the number of sit-ups Pablo had done in 1 minute for the past 7 days. This actually is meaningful, right? If you don't do the exact same amount of sit-ups every day, the average of sit-ups that you're doing over a week, you can monitor that. And what would that help you to do? If you keep taking an average amount of sit-ups over something, what does it help you to do?
You should do more push-ups or less push-ups the next day.
What does it allow you to observe?
It helps you keep and maintain a fit body, I guess,
Okay, what else?
in your progress.
Progress. It allows you to see if you're getting any better. If your average is going up, that's great. But maybe day to day, it goes up and down. It's hard to see. So, but if you do it every week and you take the average of sit-ups, then maybe you can see progress if you're getting better. Okay, so go ahead and do this problem. 2 minutes, go. Determine what is the best measure to use, go. Something happened on Wednesday. And you can use your imagination, try to think what could have happened that day. Why was it so different than the rest of the data?
Maybe because he got lazy and
Sore.
You were sore. You didn't
He slept until midnight. What?
right. And
He
you-
had to take his cat.
Pablo has the correct answer.
He slept the entire day.
Yes.
So let me ask you
24 hours
guys,
straight.
would 19 be considered an outlier then?
Quarantine.
Yes,
It's unlike
Ah.
the rest of the data. What will that throw off?
the average.
It'll throw off the average, so we can disqualify which measure?
Mean.
Disqualify mean. Is there one value that sticks out a lot?
Median
No.
or
Looks
the
like
19.
It looks like
19.
median. Now, the gap between 19 and the next higher number is not a gap that's in the middle of the data. It's a gap that's towards the end of the data, the lower end of the data. So that means that the median is a good measure here. So I'm going to use the median amount. And then next week, I can take the median amount. But you got to order them from least to greatest. So here, I'm going to do that. 19. Let's see, anything in the teens? No. Anything in the 20s? No. 30s? Yes. 37. See how I do that? 30s, that's the only one. 40s. 40, 45, 46, 49. 45, 46, 49. Looks like mostly in the 40s. And then one in the 50s. Then what I do is I check how many data points to make sure I got them all. 1, 2, it's 7 days, right? So it's 7. 1, 2, 3, 4, 5, 6, 7. Okay, that's all the data points. Now, left, right, left, right. I'm doing it with dots. Left, right. 45 was my median amount of sit-ups. Okay, next week I can take a tally of how many I do each day. And at the end of the next 7 days, take the median value and compare it to this median value. And then I can see how my progress was. See if it got better or worse. Okay, any questions about that? Yes, we are going to talk about range. We already kind of did with the climate, but we'll talk about it specifically in math. Okay, next example. Hopefully this new screen sharing is working better for you guys. I think it is. Feels like
Yeah,
it.
it's working great.
I feel like.
Mhm. And then you can always, when I go to the board, you guys can change your tab and watch me do the board stuff. So, and that means I'm not changing this. This is always pointed at my board. And really my screen is really for me to see. All right. The average wait times for 10 different rides at an amusement park. Okay, useful, right? I'd like more data than that. Also, okay, before the parks closed, we're a Disney Pass type family. We do a crowd calendar that tells you what they rate it on a scale of 1 to 10, 10 being the most possibly crowded day, you know, the park's at capacity, and a 1 would be it's empty, nobody's there.
Right now.
They give it a rating. How do they know what it's going to be? They base it on what happened that day last year.
Corona happened.
Now, well, yeah, so this would be an outlier year, wouldn't it? This is going to ruin the data if you try to include this in the data. So you have two options. You can use the median, or you can use the mean and remove the outlier. That's another thing you can do. Instead of using the median, if you really want to use the mean, just take the outlier out of the problem altogether. You could do that. You're the scientist. Remember, it's for you to use the data to make it meaningful. Okay, but this, I don't know, when would this be useful? The wait times, the average wait time would be daily. Every day the wait time was that. I mean, in a given day, it wouldn't mean much. I don't care what the average is for the whole day, because that changes at a park. When the park first opens, the first 2 hours of the park opening, the wait times are very low. People can't wake up in time to get to the park and get in the park. You have to get there early. It takes an hour once you get there to get into the park, because you have to park and walk and go through security and all that stuff. So it's really hard for people to get there on time. So I found by about 10:30, 11, that's when it starts to pick up. So if you get to the park, you get the first 2 to 3 hours at Disneyland you get on rides pretty quickly. So it doesn't really help me to look at these times to tell you what the average was for the day. You're not really gaming it well if you're doing that, because then you feel like, oh, I can show up anytime and it's going to be about that. It's not. So this is not helpful this way. So really, when you're doing data and you're doing statistics, the most important thing is to find something that's meaningful first. So where would it be meaningful? What kind of data would be meaningful for wait times? It would be that crowd calendar.
The mode?
Maybe. I mean, there's not necessarily a wrong, right answer here, but I'm telling you, the crowd calendar, if they haven't been doing it long enough, they've only started taking data the last couple of years. So it hasn't had enough time. Let's say on April 21st is a Monday this year, then April 21st next year is not Monday, so it's not the same comparison. It has to be the comparable Monday at that time. Okay, so if there's a holiday like Veterans Day, it's not on necessarily the same day of the week, right? So you have these problems that occur. So you're going to have to decide, you know, is it April 21st every year, or is it the Monday of that week of April that you're really calculating? I think you'd want it to be the Monday of that week of April, you know, I think. And then what's going to happen on that Monday that's a holiday? And then that's where I want to say, what were the wait times? Maybe I would want the average wait time that day, or really I don't want the wait time. What I want is how crowded it was. How do you measure how crowded the theme park is? Does Disney?
How many people are there?
Well, how do you know that?
How many
They
tickets
check
were
how many
given?
people come in, how many tickets are.
How do you know that? You're just you and me. How do we
You ask
know?
Disney.
You think Disney's going to tell you that?
No,
Do
probably
you
not.
think Disney knows that?
They might release the average.
Disney does know that, by the way. Disney is really big on analytics. They're big on data. They manipulate data constantly to target you and to get your money. I'm not trying to say it's an evil thing. I mean, I have a past, but that's what they do. To maximize profit, they're looking at every piece of data. How many people are there going to be this day? They're using that data to know how many people.
Someone's not muted.
How many people are going to show up for work that day? If it's going to be, if Disney knows that there's going to be a light day turnout, they're not going to have as many rides going. They're not going to have as many roller coasters going. They're not going to hire as many people to run all the things. They're not going to stock as much food, because those are all costs. And to maximize profit, it's not just how many people come into the park. It's the comparison between that and your costs, right? So they have to lower their costs on lighter days. Okay, anyway, let's get back to this problem. It's more important of what we're talking about than the actual problem, because why this is important is really more important than this. And that gives you an idea of how to actually use statistics. Okay, average wait times for 10 different rides, they already told you how many, are these. Definitely the data is all over the place. You have 11-minute waits. Those are rides that somebody doesn't really want to go on too much.
Like the bumper cars.
Yeah, and then you have the premium rides, the new ride that everybody wants to go
The
on.
cheap cup.
The roller coaster, Would the amusement park advertise the mean or the median to show that the wait times for its rides are short? So now we're talking about what the theme park wants to advertise. What is the motivation here? They want the person seeing the data to only see the median or the mode, and they want them to think that there are lower wait times. Would the median be better or the mean?
The median.
Median.
The median.
Because the mean is 30.5 and the median is 22.
Okay, so you found both and picked the one that showed lower. That's a good strategy.
Isn't the median 17?
You have to add them up. Let's add them up. 86, 90, 103, 155, 180.
I think mode.
7, 208, 230, 290, 334. So 33.4 is the mean.
I added wrong. I put 2 11s instead of 2 17s.
Now let me do this one. Everything in, okay, so we have 11, 17, 17. Anything else with the ones? No, 2s. Okay, 21, 25, 22. 21, 22, 25. Okay, anything in the 3s? No. Anything in the 4s? One of them, 44. Anything in the 5s? 52, 60, and 65. Count them. It said 10. Make sure you have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is a mode. What's the mode here?
17.
17. They didn't ask for that though. All right. But if they were going to use the mode, they would say most of our rides have a 17-minute wait. That's not really fair. Okay, that's too much. They're advertising that. Somebody's going to show up and say they're going to be angry because that's misleading. But picking the median is not necessarily misleading because you have outliers on both sides. These are outliers. Most rides are not 60 and 65 minutes. Okay, so let's go left, right, left, right. Dots are good. I like them better than slashing out so you can still see the number. Left, right, left, right. I have 2 in the middle because I had 10 data points. Okay, what's right in between?
I just move.
10. So now what I like to do, instead of adding and dividing by 2, which you can do, I like to just see first, can I find the number right in between? So it's 23.5. So if I'm advertising, you would clearly want to use the median, because you would want to advertise that your average wait time is 23.5 minutes. Okay, and people are more likely to come. Okay, there are plenty of people that are willing to wait 65 minutes. Plenty, I promise you. I see them in line. I do not ever wait in lines like that. Never. If you know how to game, you have to know how to use your fast pass.
Wow.
Here's what you do. Well, I shouldn't give my secrets away because then it'll get out there. This is going on YouTube. Yeah, I'm going to hold on to my secrets. If you want a secret person, I don't want to do it on the record. That's selfish. I don't know.
Can you put it on Schoology?
The secret away. If I give the secret away, it won't work anymore. Then everybody will do that.
How many
Put it
people
on
watch
Schoology. Only we will know.
No.
Yeah, but then you can get on some
Look
news
how many
show
views
with
this
the
gets.
life hacks for like
Maybe in office hours. Maybe
It would get so many views. You
and then
generate.
say, "Oh yeah, I'm the guy who does that life hack."
Stay anyways.
All right, let's go to this next data set. All right, Maggie ran the 100-meter dash. This is like the sit-up one, right? This is like the sit-up one. She's trying to look for progress. So this is useful for her to get some sort of measure average amount. So we're not going to calculate it this time. Let's just see which one she should use based on what you see there. Let me look at it. Don't say anything out loud. Why don't you write it in the chat? Oh yeah, all these are close together. Okay, I have my answer.
Oh.
Yeah, and you have to look at her motivation too. What is she trying to do? Is she trying to advertise or is she trying to get better? Is she trying to brag?
She's trying to get into the Junior Olympics.
Is she trying to brag? Or is she just trying for her own personal information to know where she's at so she can get better?
Maybe she's joining a track and field team.
And what's better, the lower time or the
Can I
higher
put my answer in the chat?
Lower time.
The lower time is better.
Yeah. I mean, of course. It's not like, oh yeah, I'm gonna like prove to everyone that I got the highest time. No, you want the lowest time.
Mm-hmm. Well, I guess we can put these out here. So most of our times are in the 11s. So we have 11.
I got my answer.
11.6, 11.8, 11.9.
If you did the median, you would have to add the two numbers in between and then
0.6, 12.7.
divide by 2.
Let's see, 1, 2, 3, 4, 5, 6 data points. So the median would be 11.95. The mean
would be, you just basically have to choose which one is better for the scenario.
yeah, but I'm curious to see what it comes out to.
Yeah, you kind of have to do both.
13, 22, 36, 4, 5, 6, 8, 10, 12, 1, 2, 3, 4, 5, 6, 7, 72.6 divided by 6, 1, 2, 1, 12.1.
Yeah, you do the median.
The median tells her that she's on average running a little bit faster. The median does. Because the data doesn't have any real outliers here, I don't think. This might be, I mean, it's close. I think either, you could answer, guess what? You can answer both. Both are fine. Both are good measures of the center.
Or so.
You know, and if you're working on trying to improve yourself,
You'd use 12.
maybe you want to give yourself the worst time so that you have more to work for.
Yeah.
Right?
Because I can in like this like track and field.
I have a couple people talking at the same time, one at a time, please.
Like and like track and field, like every even like tenth of a second counts.
Yes, that's true.
And if you're trying to run a
Christopher's
marathon,
right about this. Christopher's right that there aren't any outliers. So according to our chart, they probably would have said the mean is a good one to use. The average time was 12.1. But look at this, 12.1 is here. Only 2 out of the 6 data points are to the right of that. 4 of the data points are to the left of that. If you take the median, half of your times were below and half of them were above. It seems to me, I think that the median is more accurate. I would choose the median in this case.
Yeah.
All right. See what else they have for us.
There's homework.
Yay! Favorite part.
We made
Okay. So it looks like we're going to end a little early. I don't want to start the next idea. We can finish with this. Your homework is due Friday. I'm going to write it down. And you are dismissed. We are on office hours now.
Stop recording and tell us your secrets.
Yeah, I will stop recording.
maybe
Okay.
after the quarantine.
What would be the use of exactly the quarantine? What would be the use of it? Probably wouldn't remember it anyways.
Yeah, exactly. Like,
I've gotten reports that Disney might not be opening back up till next year, 2021.
Exactly.
Yeah,
So you'd
concerts are
probably
staying
forget.
closed until August 2021, stuff like that.
Even if
also
the
people
virus
are probably
wasn't
not going to
ready,
come to Disneyland because they're still going to be germophobic.
would happen, like if like low
Could you please tell me to work on another theme park?
The vaccine is probably coming out next year, so people are taking as many precautions with their businesses as possible.
Yeah.